So now let's see how the questions come, exam setup. Mr. Tembo, like the previous exam, Mr. Tembo has 1,000 to deposit an account that earns 9% interest. Find the future value after 5 years if computed at simple interest. So simple interest is PTR. What is this 1,000? Our principal. The time is 5 years, and the 9% is our simple interest. So the simple interest becomes 450. All right. But the future value is what they're being asked for after 5 years. So future value is simply simple interest plus the principal amount. So 450 plus the 1,000 gives us 1,450. Now we want to compute the future value using compound interest. Compound interest is future value 1 plus r to the power t. So our r is 9%. Present value is 1,000. So when you compute it, you get 1,538. You see the difference here. This is more. The interest is 500. This one, the interest is 450. Then further, the examiner will ask you now, suppose it is computed at semi-annual. What is the compound interest? For semi, we use this formula now. Semi means what? 2 times. So R over M, the time will be multiplied by 2. So the period will be 10. The 9% annually will be divided by 2. So it will be 4.5 every 6 months. So we're going to have 1.045 to the power 10. So our interest now is by a small margin. Okay. Then we proceed. Suppose it was computed quarterly. So quarterly means what? Our M is equal to 4. So we're being asked to find the effective annual rate and also the future value under compound interest quarterly. So only difference is here, we're going to put a 4 and the 4 there. So our interest will be 2.2% per quarter for the whole year, which is 4 times. So it will be 1.0225 to the power 20 to give us 1,560 as the future value. So the amount is increasing as you compound 1,552. Here it was what? 1,538. 1,552. Then now we're going to 1,560. Then the effective annual rate. Sometimes you're asked to define what the effective annual rate is. So it's important to understand the effective annual rate really is the truest interest rate on an investment, or the truest rate that is charged on a loan, because it takes into account the effects of compounding. So the effective annual rate and the annual equivalent rate are simply a percentage on a loan. It accumulates over a year. It gives you the real value. Okay, so now we have calculated our effective annual rate as 9.2%. This is the actual rate that you earn, not the 9%, but it's earning because of compounding, 9.31%. So if it was monthly, our M is what? 12. So the actual rate, instead of 9.31, it would be 9.38%. Suppose it was compounded continuously. Our future value will be present value e to the power RT. So 9% times the 5 years, our future value now becomes 1,571 because you're compounding continuously. Weekly, you use 52, monthly 12, daily 365, and this you can try at your own time. So this is basically what we discussed. I hope we're able to follow through. Now we go to our annuities. The other part I talked about is, suppose you're being asked, Mr. Tembo wants to earn 5,000 after 4 years at 8%. How much must he deposit now? They're asking for the present value. So present value, if you're not sure of this shortcut formula, just start from where you know. Future value is equal to what? Present value, 1 plus r to the power t. This is if they're compounding annually. If they're compounding more than once, then use this general formula. Present value is equal to 1 plus r by m, and this is mt. But please note that if you are calculating the effective annual rate, there's no time aspect. It is simply 1 plus r over m minus 1. I'll give you the previous part-time test so that you can look at it, where he was asking for these simple things carrying about 9 marks. That will be your homework. So Mr. Zulu repeats questions. So I want from the onset, we get to see how he does the questions. So here, future value becomes divided by this whole part here to make our present value. It's the same thing. So how much must Mr. Tembo deposit now? So 5,000, 8% to the power 4. If it was semi-annually, we divide this. Even if you're using the annual here, it's 1. 1 won't make a difference. It will still be the same. Semi-annually, we put a 2 there and a 2 there. So we'll get this figure there. The other thing is, how long will it take for Mr. Tembo to double his 5,000 at 8% compounded annually? So to double means what? Multiply by 2. So meaning the future value will be 10,000, present value will be 5,000. It's annually, we use this annual formula. Our rate is 8%, so 1.08 to the power t. And divide this, we're going to get a 2. For this t to fall down, we introduce logs. The t will fall down in there so that we divide by 1.08 on both sides, and we get 9 years. So it will take 9 years for this amount to be doubled. Also talked about how to calculate time. Now, this takes us to another key topic, which is called annuities. So what are annuities? Annuities are a series of equal periodic payments that are made either at the beginning or at the end of a period. So we have payments that are made on a periodic or specified period of time, which are equidistant. Okay, so kinds of payments, we include loan payments, car payments, insurance premiums, mortgage payments, and retirement payments. So if they're made at the beginning of the period, we call them annuity due, like rentals. If they're made at the end of the period, we call them what? Ordinary annuities. Now these ordinary annuities, we'll use the formula to understand them. To start with, these are series of payments. They're either future values or present values. So I'm going to use the same formula that we used earlier on to understand this concept. For instance, you have 1,000 kwacha at a rate of 8%, compounded annually for 3 years. How much will you have in future if you're paying at the end of each period? So you're talking about 1,000, 1,000, 1,000. This is year 1, year 2, year 3. Ideally, we're supposed to get a 3,000, but because there's some interest that is earned, we'll get slightly more than 3,000. So this one, to reach year 3, future value will be simply present value 1 plus r to the power t. So it will only stay how many years? 1, 2, because at the end of the period. So it will be 1,000, 10%. This is 1.10 to the power 2. This will give you 1.10. This one will stay at the end of the, was starting at the end of year 2, the end of year 3. It will only stay how many times? 1 year. So this will give you 1.10 to the power 1, which will give you 1,100. This one, since at the end of the day, it will not accrue any interest. Some period of time would have elapsed to the power 0. So it will still remain as 1,000. So these additions of these payments, total them up, we're getting 3,310. So the total is what we call an annuity. So this is called the future value of an annuity. We use FVA. The way you do your Chidimba, you are making payments at the end of the month. 1,000, 1,000, 1,000. How much are you going to get if you've made 10 deposits of 1,000? You're not getting 10,000, but you're getting an interest there. So these periodic payments, by now you need to evolve in how you speak. Your financial students, you call them annuities. You're in your Chidimba meeting, say these are called what? Annuities. Why? They're paid at a specific period and the amount is similar or the same. Now there's a formula that we use. The rate is what? 10%. The time is what? 3 years. And the amount that we are paying is how much? 1,000. So we call that the future value of an annuity is given by payment for the present value. And here you put 1 plus R to the power T minus 1 divided by R. So this payment is 1,000. The interest rate is 10%. So 1.10 to the power 3. And here it is just a rate, which is 10%. If you do your math properly, what you're going to get inside here is 3.310. So the total here will be the same figure we got, 3310. This is called your what? Future value of an annuity after 3 years. Remember, if it's at the end of the period, it is called what? An ordinary annuity. If it's at the beginning, it's called a what? An annuity due. So we have 3 or 4 annuities. There's future value of an ordinary annuity. There's future value of an annuity due. There's present value of an ordinary annuity and present value of an annuity due. To find an annuity due, you simply multiply the ordinary annuity times 1 plus R. To find an annuity due, you simply multiply any of the annuities, but just multiply it by 1 plus R. So the answer we get here, the 310, since our R is 10%, we just multiply this by 1.10. 1.10. So we're going to get 3641. So meaning this is the amount that we get if the amount we paid at the beginning of each year. Similarly, if you are looking at the present value of an annuity, present value is simply asking yourself to say, I'm supposed to be getting rentals from these, my tenants, year 1, year 2, year 3. These 1,000 kwachas are supposed to be taken today. Now, since you're demanding money now, how much can they give you now? Because of inflation rate or the interest rate, this money is supposed to be lower. So you're going to discount each of these here. Find the present value here, the present value here, and the present value here. Remember, present value is simply the future value, 1 plus R to the power time. So for the first year, this 1,000 kwacha, 10% is 1.10 to the power 1, the present value for year 1. Present value for year 2, 1,000 kwacha, the way we're doing NPV in financial accounting, to the power 2. Year 3, 1,000, 1.13, and 0 to the power 3. So the answers, when you add them, this is called an annuity, called present value of an annuity. Because of time, when you calculate it, you're going to get this figure here, which is 2487. So this is what we're going to get here. The sum total of this is what? 2487. This is called the present value of an annuity. Now, how do we get the present value of an annuity due? Can somebody guess? I already mentioned that. How do we get the present value of an annuity due? You simply multiply the ordinary annuity times what? 1 plus R. So 2487. Since the rate is 10%, the same figures I was talking about, you're going to get the present value of an annuity. Time value is the toughest topic of this course. It requires you to understand every principle. Finally, this takes us to the exam questions here. So Mr. Tembo decides to deposit 1,000 every year from now, year 1 to year 3 at 10% compound interest. How much we have if he has made at the end of the period? So this is the future value of an annuity. Okay, at the beginning of the period, this is the future value annuity due. You multiply the answer by 1.1. Now we're remaining with 7 minutes so that we go to POM. So quickly, it takes us to another concept of loan amortization. Amortize a loan is simply to set up a payment period or structure in which you can liquidate a loan within equal payment structures. Loan amortization is what most of these firms that deal with hire purchase use. So loan amortization is important. The formula is given using the present value annuity. It's the amount of loan, the payment, then we have the present value annuity formula. I don't know whether I showed using the formula here. I only use the number line. Let me get the present value formula. So to find the present value annuity, I didn't show you the formula. It's given by payment. Then here it is 1 plus R to the power negative T over R. Compare the future value annuity, slightly different. Here we're going to have payment, and here we're multiplying what? 1 plus R to the power positive T minus 1, everything over R. So there's some swap for future value. This one comes aside, but the power is positive. For the present value, this one goes aside, but the power is what? Negative. So our amount was 1,000. Our interest rate was 10%, and the time we had was 3 years, and the interest rate was 10%. So this one here will take us to 0.487. So this is what will give us the same figure. We got 2487 as our present value annuity. You will, however, be given tables to use, but I'm so keen at you using the formulas because sometimes the tables, when you're given an interest rate that is not on the table, like 2.5, you'll be stuck. So this is the safest that you need to have. So quick, can you remember? Give me, if payments are made, equal periodic payments are made at the beginning of the period, it's called what?
Due.
Yes. If payments are made periodically at the beginning of the period, what is it called?
Annuity due at the beginning.
Yes. If it's at the end of the period?
Ordinary annuity.
Ordinary annuity.
Give me examples of annuities that you know.
Annuity due example, rent.
Okay.
Because we're paying that.
Yes, ordinary annuity.
Then ordinary annuity, maybe a loan.
A loan, okay, on the month, then yes, a loan, correct. Okay, so we now want to amortize a loan. Loan amortization is making a schedule to repaying a loan with a specified period with a fixed monthly repayment. So the formula is given by the amount of loan, the payment, then we have the present value, annuity factor. Annuity factor, remember the formula, 1 plus R to the power negative T, everything over R. Our example, suppose our loan was 1,000 and our interest rate is 10% and the period of time is 3 years. Part A, find the periodic payment. Part B, amortize the loan. Set up an amortization schedule. So let's calculate the payment. So using this formula here, part A, the amount of loan is 1,000. The payment, we don't know. So this is 1 minus 1.10 to the power time, which is negative 3. Then the interest rate is 10%. So here we're going to have 1,000. Then here we're going to have what? 2.487. So when you divide it on both sides, what becomes our payment? 1,000 divided by 2.487. So what do we get? We get 402. Okay. 109 if you like. So this is how we calculate the periodic payment. Then we now need to set up the schedule. Okay, so let's go through this quickly. Mr. Tembo decides to borrow 1,000 at 10% for 3 years. Part A, compute his annual periodic payment. So what did we say? The formula, amount of loan is what? Payment. Then the present value, annuity, which is 1 minus 1 plus R to the power negative T over. Here we have what? 1,000. Here we have what? Payment, which we don't know. Then here we have 1.10 to the power negative 3. Then here we have 10%. So this will be what? Payment. And here we have what? 2.487. So when you divide on both sides, our payment becomes what? 1,000 over 2.487, which is 402. And to set up our amortization schedule, we use this table here. We have 3 years, 1, 2, 3. The amount we started was 1,000 baht. The equal periodic payment we've calculated is 402. So you put the 402 in here. Then the interest paid, so we can call this column 1, column 2, column 3, column 4, and column 5. So how do we find the interest paid is 10%? So column 1 times 10%. So 10% of this one is what? 100. To find column 4, we subtract column 2 minus column 3. So this minus that 302. Then to find column 5, we subtract column 1 minus column 4. So column 1 minus column 4. What do we get? 1000 minus 302, 698. So this becomes our opening balance here. So column 1 is simply column 5 brought down. So again, how do we get the 10% of this one? 10% of column 1, which is 69.8. How do we get this column here? We subtract 402 minus what? 402 minus what?
69.8.
So this will give us 332.2. Then how do we get this column here?
$698 minus 332.2.
Yes, which is what? 365.8, which comes here. 365.8. Then how do we get the answer here? 10% of that, which is at 6.58. And how do we get this column here? We subtract this figure minus that to give us 365.8. Then we subtract. How do we get the last column here?
Okay, no problem.
365.8 minus 360. Oh, so yeah, this
So we
one.
get a 0, meaning would have paid off the loan. So this is what we call loan amortization. So this is how we do the computations. So I'll give you homework based on the test and what we've covered. So we're done with loan amortization. Tomorrow we start bond valuation. Then we go to stock valuation. Then we go to cost of capital, dividend policy. Then by next week or the other week, the whole syllabus will be done. Then we start revisions. So this is basically time value, the longest topic and the most complex. Any questions?